Here we have a Mercedes-Benz key fob that was mailed over for repair. I'm reading what the customer wrote, and it's not much. Won't start or open the door to my car. That's all what the customer wrote. Straight to the point. I know what's going on. Key fob is not working. It's not turning the vehicle on. It's not opening or closing the doors. Now the key fob came in a shell like this. The shell is totally broken from the front. You can see the circuit board. So I had to just take out the motherboard like this. We're gonna replace the shell for the customer. I have a lot of used ones in here. And let's take a look at the fob and why the fob is not powering on or not working. The first thing I see is a missing infrared component. That component should look something like this, and it's missing. That's number one. It looks like the fob may have suffered liquid damage. I can tell by the stains on the board. I do not see anything obvious here. The button clicks. Button clicks. Oscillator is present. All the components are present. This is empty by default. Empty by default, empty by default, and I do not see anything wrong on this side of the board except for the missing infrared component. Let's flip the board. Take a look at the back. The coil is solid. And I do not know if this line is continuous or not. The line may be broken, but we're gonna have to find out. We'll use our grinding pen and measure from here to here and see if we have a continuous line. If not, then that may be a problem. We need to restore this line. The only thing I see wrong, possibly this line and the infrared component that goes on the front. Let me measure the coil, make sure it's continuous. Meter in continuity mode. And we're gonna measure from here to here. Not here, here. We are good. We're good. The coil is good. All right, let me grab my grinding pen. And I think we're gonna only grind from this area, and we can measure from this point, from this test point, all the way here. Let's measure from here to right here. And we do not have a continuous path. Let me grind some more. And we're going to use our empty glare light. And we're going to measure from this test point here, because you can tell the line is going from here all the way, all the way. You see, up to here is good. But as we start to go down, the line breaks. So we know that we have a problem here. Add some flux. Amtech 559 flux. And we're going to use our NF dot mini pen and tin those traces. I need to grind some more from this far end here. Very nice. And we can tin along the way also. It does not hurt, because the wire, we're gonna run the wire from here all the way here, and we can solder it all the way across. I do not know if a pad strip would be long enough to use here. We may have to use enameled or non-enameled wire. Will that wire work? Yes. The wire is a good length. We're gonna grab it and start soldering from right over here. Very nice. Now we're gonna shape that pad strip so it's round. Just making sure the board is clean because we're gonna apply UV mask. But before we apply UV mask, I want to measure to make sure that we have a continuous path right now. And we're gonna measure from the test point that we have on the far left, from here all the way to right here. See? Done. Let's apply UV mask. And all the tools that we are using in this video can be purchased from our website. Just log in to NorthridgeFix.com, click on shop, add whatever you want to cart, check out. All items are in stock and we almost always ship out same day. You can purchase everything from a UV mask, UV light, flux, tweezers, hot air station, soldering station, thermal camera, everything. We sell what we use, so we know that everything that we have on our site is useful and money well spent. Especially the microscope that we are working on right now. We are currently out of stock on the microscopes, but we have a shipment coming in possibly by next week. We do have the back order option on our site, so if you want to secure a microscope, just log in, order, and as soon as we have the microscopes back in stock, we will ship out the microscope to you. So that's what I do. I put a little bit of UV mask on the blade, and then with my tweezer, with the tip of my tweezer, I take some out and I apply it. Now we're going to use our 10-watt UV light. And don't worry, I'm not going to shine the light like this so you do not get a tan or get hurt. You know what I'm talking about. The new viewers to the channel probably do not know what I'm talking about. But we had a viewer that complained, why did I expose him to UV light? He's in another country. So somehow he got UV light through his TV, through his monitor, and he was exposed to UV light. Sometimes you just have to learn to be patient. Like we had a customer who came in, and I did mention it in one of the videos. She asked that we change her digitizer glass on her iPad. We did. She came to pick up the iPad. She was very happy with the iPad. She came back after 2 months and her iPad was bent like this. And she said that because we changed the glass on her iPad, after 2 months, the metal housing bent. In this business, you develop thick skin quick. So now what I want to do is apply a little bit of hot air. And we are done. We are done with this area of the board. Let's clean up one more time. Very nice. We did an amazing job. Now we're going to work on the back side of the motherboard and replace the infrared component. And where do we get an infrared component from? That's a good question. We get it from a donor board because we have 6 million Benz donor motherboards here in the shop. We fix Benz key fobs every day. And right off the bat, I grabbed just a random motherboard. You can tell we removed the chip from that board. And we have an infrared component right here. Now this infrared component is very fragile. We cannot use our hot tweezers to remove that component because we're going to end up squishing that plastic infrared component. If we apply a lot of heat, it's going to end up melting. So what should we do? We have two options. We can apply heat from the bottom here, and look at this. We use the infrared component on back of the board, and we also use this capacitor here and a few other components. So we can apply heat from the bottom to safely desolder this component, or we can even apply hot air from the top, but we have to be careful. Let's apply hot air from the bottom. And this board is only 2 layers, so it does not take much heat to desolder components. The board itself will reach melting temperature of solder pretty quick. Let's apply heat from the bottom. And we're going to use our fine tweezers to grab that component from the sides. We do not want to press too hard. Like I said, this component is plastic. And we do not want to break it. And let's go back to the customer's board. Right here. And make sure that we have the proper orientation on that infrared component. We need to apply a little bit of flux and solder. But how are we going to solder that component? We cannot apply heat from the bottom because we have a similar component right on the bottom. If we apply heat from the bottom, then we're going to end up melting that component. I do not want to apply heat from the top because I have other options. We're going to use our NF.mini pen and apply just a tiny bit of heat on the pad itself and not on the component, because as soon as we touch the soldering iron tip on the side or to the side of the component, it's going to melt. I know this because I work with them every day. Just a tiny bit of flux here and a tiny bit of flux here. And let me rotate the board holder in a way where I'm comfortable. And now with the tip of my NF.mini pen, I'm not going to touch the component, but I'm going to touch the pad. See? Just like that. We soldered one side and we did not touch the component itself. And we're going to do the same thing to the other side. Rotate the board holder. Because what happens is as soon as you touch the component, the plastic on the component will melt. And it will deform. So we're going to gently press down on the component. And I mean gently. Do not puncture that component. It has soft plastic. We're going to apply heat just on the pad itself and not on the component. And we are done. Look at this. Look at the soldering on this component. Better than factory. No doubt. And if we inspect under the microscope, look at this. Look at how continuous the solder is from the component itself all the way down to the pad. And let's check the other side. And the same result. Amazing. We did an amazing job. All we have to do is test. Make sure that we have the right frequency output and we have an infrared output, and we're going to deem it a fix. Now what I want to do is measure the batteries that came with the fob. I want to make sure the batteries are good. Oh, excellent. We have 6.5 volts on both batteries, and that's very good. Just placing the batteries in the battery holder, and the battery holder does not look good, so we're going to have to give the customer one, a used one from our shop. I have a lot of Benz shells. And this one looks good. This one actually looks very good. I'm going to put the motherboard inside the shell. And the battery holder. And we're going to test. Yes, we are now getting the red blink. I do not know if you can see it when I press on the button. But we're going to have to test it using the fob tester. Right, maybe we can go under the microscope. Okay, so I'm going to press on the lock button. We see 314.9. That's very good. Lock 314.9. I'm going to press on the trunk button. 314.9. And I'm going to press on the panic button. And we also have 314.9. Now we want to test the infrared signal, and what I do to test the infrared is I point the fob on the very top here and I press the button, and we should get a reading of IR to indicate that the infrared is working. So button 1, we have IR. The trunk button we need to press and hold, and now we have IR. Lock button, very good. And trunk button, excellent. The fob is fully functional. We're going to invoice and mail this back to the customer. I hope you enjoyed the video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.